Devesh.
Good afternoon, everyone. I'm delighted to welcome you to today's webinar. It's an honor to introduce our esteemed guest for today's webinar, Mr. Devesh Kumar. Hello, Devesh. An experienced polyglot developer
Hey, hi.
and Sun certified developer. Hi. With 16 plus years in IT industry across banking, healthcare, and HCM domain. Today, he is going to share some valuable thoughts on effective coding practices. Without further delay, I invite Mr. Devesh to share his expertise with us.
Okay, thank you so
Over
much
to
for
you,
that nice
Devesh.
introduction. Yeah, thank you so much for that nice introduction. Hello, friends. How are you? Hello, are you there?
Yeah. Hi, Devesh. We are good. How are
Yeah.
you?
Hey, hi, everyone. Good to hear. I was
Hi.
not expecting anyone to speak anything because this is a post-lunch session, and that too, it's a Monday. So I was telling Saurabh, let's do it in the morning, but he insisted on doing it in the afternoon. But we will try to make it fruitful. So, so we were like thinking, like Saurabh and me, we were thinking of doing this session, and then Saurabh told me that let's talk about something which is, which helps the engineers on a day-to-day basis, which is something which they can use in their day-to-day lives. And that is when, this particular topic came to my mind, that I don't think there could be a better topic to discuss with engineers. So with that thought in mind, like I thought that let's talk about how we can write better code, effective code, clean code, using and leveraging the object-oriented design principles. So that is the topic of the day. And the reason we are going to talk about it today is because this is something which is applicable to any engineer, any developer. It doesn't matter. He might be a backend engineer. He may be a front-end engineer. He may be a data engineer. It applies to everyone who's associated with code some way or the other. Okay, so as part of today's session, so what I'm trying to do is I'm going to answer three fundamental questions. First is going to be why. Why should I know design principles? Because it's very important to first understand the why of anything before we really pick that thing up and start learning. So first we are going to understand why. Second thing, we are going to understand what are we really talking about? What design principles? What are they? And then third, it's going to be how I can apply these design principles. How can I use it? So we are going to take some examples. We are going to look at live code, how we can apply it. So with these three questions, we are going to, this is the context that I'm setting up for today's session. So let's get started. Okay, so I'm going to share my screen now. Just a minute. So let me know once you see my screen.
Yes.
Screen is visible? Okay. Okay, fine. Okay. So 1 minute. Okay. So today's topic that we know is writing better, clean, effective code using object-oriented design principles. Now, what are we talking about? We are basically talking about a very age-old design principles which is there in the industry for very long. So this is not something that is new in the market. This is there since more than 20 years. So to be specific, so there was this guy called as Robert Martin, who's a very famous person in the tech industry. He's a well-known author. He's very belovedly known as Uncle Bob. So he was the one who first invented these 5 principles, which is acronymed with SOLID. So he basically, invented these things in way back in the year 2000. He wrote a white paper called as Design Principles and Patterns. And then these concepts, these principles were later adopted by a guy called as Michael Feathers. And he actually coined this abbreviation or acronym called as SOLID. And then this name got very popular. Why it got popular? Because the tech industry, the programming communities, the technology communities, they found sense in this because they felt these principles are very relevant. It's very relevant to our day-to-day programming lives. People who are working on code, they may be coding, they may be reviewing the code, they might be reviewing the design. Anyone who's associated with these things were so and so important and so relevant. So that is why these 5 principles became so popular. But the unfortunate thing is, like, even though they are so popular, there's still a lot of neglect. Lot of people, lot of engineers, they don't really pay attention to these 5 principles. So that is why I think, we should talk again about these design principles and understand how it can really help us. Okay, so with that said, I just want to ask all the people here, have you heard about these solid principles before coming to this meeting? Anyone?
No.
Okay, fair enough. No worries. Then this session is going to be more helpful for you. Okay, so with that said, what are these 5 principles? The first S stands for single responsibility principle. O stands for open and close principle. L stands for Liskov substitution principle. So Liskov was basically a scientist and engineer. So he basically created this principle. So this name came out of it. Then I stands for interface segregation principle, and D stands for dependency inversion principle. Okay, so these are the 5 principles today that we are going to talk about in detail. Okay, so now moving to the next slide. Now the first question comes that I said, the 3 questions we are going to answer: why, what, and how. So the first question we have to understand is why solid principles matters at all. So there are 2 fundamental reasons to it, which we need to understand. And this is not something which is bookish. This is industry practice. It is an industry observation. You go to any domain in the IT industry, in the software industry, you will see this pattern. What is it? First reason, nature of project development in industry. Now, when project development happens, there are only 2 types of project development that happens. Either it is going to be a greenfield development, either it's going to be a brownfield development. What do you mean by greenfield development? Greenfield development means nothing but a project from scratch. You are building an application from scratch. It could be like you want to build a new website, or you want to write a brand new microservice, or you want to build a brand new tool, or it may also be you want to migrate a big application which is there. Let's say it is in monolith or it is in some other programming language, but you want to migrate it to, say, some latest programming language like Go or Java or whatever. Even that would be under greenfield migration. So basically, greenfield means anything you're doing from scratch. You don't have a reference point to it. Brownfield development is typical projects that we work on a day-to-day basis. Your maintenance projects, your enhancement projects, your bug fixing projects, your support projects, these are all brownfield projects, which means nothing but you already have a reference and you are building on top of it. Now, if you look at these percentages, what they mean, generally, it has been observed that 25 to 30% of the projects that we do are greenfield in nature. Most of it, 70 to 75%, even maybe more than that, are all brownfield development types. Why? Because technology is funded by business. If there is no business, technology doesn't make sense. There's no sense of building a project if there is no client, if there's no one to buy that particular product and use it, right? We create a new application, we create a new product, but we need to monetize it. We need to sell it. We need to have clients. So once we build it, we maintain it forever, right? We maintain it forever. We need to maintain it. We need to enhance it. We need to support it. We need to do bug fixing. That keeps on going as a long going business. That is the first reason. So the major area of operation for all engineers is basically brownfield development, right? Now, what is the second reason? The second reason we have to understand is the way human brain works is very different to how computer processors work. How? Basically, we human beings, we are engineers, we are programmers, but we like aesthetics. Aesthetics basically means We like things which are organized, which is neat, which is put in a structured and proper manner. We don't like things which is just like, everything put in one huge, in one big junk. You just put it and just give it, even though it works, but we don't really appreciate that. It doesn't really make so much sense to us, right? So but if you look at a computer processor or a machine, how does it work? It doesn't really care about aesthetics. It just cares about what input you are giving to him. So let's take the example of coding. If we are talking about coding, right? So let's take an example, like if I am a developer, right? And let's say I'm going to give you one file and I'm going to tell you. So let's look at this file just to explain what I'm trying to say. I'm giving you this file. So let's assume this is not a small file. This could be like 100 KB file I'm giving you. It has all the code of a client's project and it's working fine. And I give you this code and I tell you that go and understand this code because we need to add more functionalities and features to it. So I just give you this code. This is still a small one, but real life project, it could be 100 KB, 200 KB file, right? You can just imagine like 1 lakh line, 1 lakh, 2 lakh lines of code is there. And I just give you understand the whole project is in one file. And I tell you understand that and make it work. Okay. Now you would say it is difficult. I can't understand. There's so much thing. You'll just feel like just, pulling your hair apart. But if I give this same file to a computer, to maybe to a programming language interpreter, I can give it to the compiler and say that take this file. It doesn't have any compilation error. You just need to take it and execute it. Or the computer processor will take it, he will run it, and he will give you the output. This is the difference between programmers and computers. We as programmers, we like things which is organized. We like things which is structured, which is put in a proper formatted way. And that is where these design principles come into picture. That is why they matter. Why? Because these design principles help us be more structured, more organized in our code. So with these two fundamental reasons, design principles become very, very important for us. Okay. Now, you will say, Devesh, now you told that design principle matters. I understand that, but still you would say my code works. I am a programmer. I have been programming for like 5, 10, 15 years. I know programming language very well. I have delivered a lot of projects. I have delivered a lot of client features. My client is happy with me. So why should I still learn? Why does it still matter to me? Now, if you see, there are only two types of codes. There is a code and there is a good code. Okay. Now, when you talk about normal code or bad code or whatever you call it, a code that works, it just works. Whatever functionality features you have, it works. Okay. You deliver the product. But there are some fundamental traits, some attributes which make this code termed as a bad code or not so good code. What are they? Typically, if you see code which is not so good, it will always be hard to fix. It is hard to maintain. Why? Because these codes have side effects. What is the side effect? Side effect basically means that if you do a bug fix, you say fixed in one file and you didn't realize it broke somewhere else. Or it could be something like you had implemented a code in 3-4 different places. Now it could be you are a new developer in the team. You just knew that it has to be fixed in one place. You went ahead, you did that fix, but the other 3-4 places were just left out. Or something broke because you were not aware of the full functionality of the application. So code can have side effects. You fix in one place, it breaks in some other place, which is hard to debug, and life becomes challenging. So that is why bad code is hard to fix because it has a lot of dependencies here and there. And secondly, what is the downside? It makes your development timelines go longer, and which nothing but has a direct impact on your maintenance cost, on your project cost. So it is that very important. It has a direct impact on the revenue, on the cost that the company is bearing on the project, right? So these are two very strong reasons which should make us understand that solid principles does matter, even though I know coding. And the third fact is the application will be there when it's newly built, everything looks good. But after 1 year, 2 year, 3 years, 5 years, the application will become bigger and bigger. It will start showing its age. And when it starts showing age, you will start facing all these challenges, problems, and that's why it needs maintenance. It needs maintenance. It needs refactoring on a regular basis. Now, let's talk about the benefits. We talked about why. Having understood why it's important, let's understand the benefit. The benefit is very clear, very visible benefits: maintainability, readability, modularity, extensibility. Your code is much more maintainable. Your code is better readable. Your code is modularized. Every concern, every feature, every functionality is kept in a separate module. They are not crisscrossing each other. Extensibility. If you get a new feature, it's not difficult to extend your code, right? And the next very important point is solid principles reduce your regression testing impacts. Your regression testing impacts comes down, and that is a very important point. Imagine you do a bug fix for just one client, and you go and tell your QA that you need to test the whole functionality out for all the clients, because the code has been built in that way. You need to do a regression on everything. You have increased the risk, and that has a direct impact on the cost, because if something breaks, you have to again go back, again fix it, again revisit the code. Very important factor. Next point is it increases the business agility. It gives more confidence. When the code is more structured, more modular, you as a developer feel confident. Oh, don't worry, this fix is only for this particular thing. There's no impact in any other place. Don't worry. You don't need to test everything. Just test this one. This will work. That has a direct impact on the business agility. You can roll out features faster, right? The third point, the next point is basically it is a programming language agnostic principle. These principles doesn't matter for just Java or .NET or Python. It applies for a front-end developer who works on TypeScript. It applies for a data engineer who's working on Python or R. It applies for a backend developer who's working on .NET, C#, Scala, Go, whatever. These principles apply for everyone. Next, design principles are technology agnostic. It doesn't matter whether we are living in the age of monoliths, or we are living in the age of service-oriented architecture, or we are living in the age of microservices today. Today, if we talk about monolith architecture, everyone say, hey, I work on microservice architecture. I don't work on monolith. That's very old. But these design principles still make sense. You can apply it in a monolith project. You can apply it in a microservice project as well, right? And last very important point to stress about is we are talking about design principles, but patterns themselves use these design principles. A very important point: design patterns are a derivative of solid principles. Okay, so with that said, now let's move to the first design principle. Now, before I start with this first design principle, I just want to take a pause and just ask, any thoughts, any questions so far? Hello, guys, are you with me?
Yes.
Okay.
Yes.
Okay. I thought everyone slept.
No.
I just
We are
wanted
not
to do
sleeping. We are enjoying.
Oh, you're enjoying. Okay.
Yes.
Okay, just kidding. Okay, so now let's move to the first principle, single responsibility principle. The name is very simple. This is a very simple principle, by the way. The name itself explains single responsibility. Okay, so what is this definition in this highlighted bold? Every software component should have one and only one responsibility or reason to change. So basically, it says that it could be any software component. It could be a method, it could be a class, it could be a package, it could even be a application. like say microservice. Microservice are basically architectural patterns, architectural styles. Even architectures like microservice follow this single responsibility principle. Why? Because when you build a microservice, you build it for only one functionality, one feature. Like if I build an e-commerce application, what is the MVP? I should be able to search the order. I should have products in my inventory. I should be able to order. I should be able to make payment. I should be able to ship. I can create 5 different microservices for each and everything. So even they follow this SRP principle, single responsibility principle. Why we should follow SRP? What is the advantage? The advantage is it gives high cohesion, loose coupling. What do you mean by high cohesion and loose coupling? Anyone can take a guess what this high cohesion, loose coupling means? Any thoughts?
High performance value with low chances of bugs.
Your voice is a little low. Can you be a little louder?
Uh, high high in the performance and low in the bugs.
It's not really performance. Okay, so basically cohesion. Cohesion, what it really means is basically, it's basically you have say, let's take an example of task force commando. You know these, right? Marine commandos and all. They work in small groups. Typically, you will see they are like a platoon of 5 or 10 commandos who go on a mission. They are highly cohesive. Why? Because all of them are working towards just one target. It's their mission. They are not like working on 5 different missions. They are working on one mission. That's what high cohesion means. You have to be as a unit, as a component, you have to be cohesive. All the code that you write in the method or the class should be focused on only one mission, only one task. That is what high cohesion, right? And low coupling basically means is the interaction or the binding or the wiring between the different classes should be less. Why? Because it should not be so hardly coupled that if I do a change in class A, I have to also go and change class B. That's not a good practice. So that is why SRP says high cohesion, loose coupling. We will see that in examples. When we come to the example, it will be more clear. Okay. And the fourth point is basically a caution, a word of caution for you. So we will talk about it soon. Now let's go to the code and understand. It will make more sense. Okay, so okay, so let's take examples. SRP, single responsibility principle. Let's take one example. Now look at this code. I have kept a simple code so that it makes sense. We have to understand the principle. So I have kept it little small. But in real life codes are, I know projects, the application codes are very huge. But just for the sake of understanding, let's take this a clear violation of single responsibility principle. This class is. Now let's say we are an e-commerce application and the user is submitting the orders and we want to process the orders. And I have created an order processor class whose responsibility is to take the order request and then do all the checks and balances and then persist the data, send it to all the downstream systems, whatever there is, do everything. So if we look at this particular class, now let's say it takes this request object order DTO, which has basically order ID, order name, what is the total amount of that order, item IDs, basically what items I have ordered. So the item IDs, we are just taking the ID of that item that you're ordering, and then we have payment method identifier. It could be like Google Pay or credit card, whatever, and then order date and ordered by. Simple. So what this order processor first does is it first goes and just validates the object. Okay, it just checks the object is clean or not. Second, then what it does is it takes these item IDs, the order item IDs. It goes and check that is there any invalid item ID in this particular order. If there is any one, then I say invalid item IDs in this order, I throw an exception. But if the order is good, no validation problems, then what I do is I will first convert this order request object into the order entity. Like entity is nothing but whatever database oriented objects that we have created, which is persisted into the table. Let's say we have an order table. So analogous to that, we have an order entity. It is the same replica of order DTO. Okay, for the sake of understanding. So I convert that order DTO into order entity. And then the next action that I do is I persist that, I save that into the order table, and then I also send it to the audit table. I do this business and persistence logic, and then once it is successful, I have to send this order, newly created order object, to the downstream systems. Like it could be to the shipping service. I have to inform to the shipping service. I have to inform to the inventory service. So I'm just going to drop a Kafka. It could be any messaging broker. Let's take Kafka, which is like very common these days. So I send a message to the Kafka, and then it does all the stuff. Now, this is my example that we are going to discuss for single responsibility principle. Now, what is the harm in that? What is bad in this? Nothing bad. This code works. It's fine. But the challenge here is this order processor is doing just too many things. By the way, this is just like 50 lines of code, but in real project, it's going to be 500 or 5,000 lines of code. I have myself worked in projects where the number of lines of code in class is 25,000. I have seen code 20,000, 25,000 lines of code in one class, where I have literally pulled my hair apart to understand the code. So things are so nasty in the real project, but this is just a simplified version of that. So here the violation is very straightforward. This order processor is doing multiple things. It is validating here. It's doing the validation. After that, it's trying to do some mapping. Now, this is a simple mapping. In real life, you could have a lot of mapping logic. You'll have to call some different DAO, some service. You do the mapping. After that, you might have some complex persistence logic. You'll have to do all that stuff. And then you have to convert it into some complex Kafka or some messaging object. You have to do all that conversion, then make a call to Kafka. You do all those things. You are doing it all in one place. But what is the downside? What is the harm in this? The first harm is, if you look here, if you see this place, now I have just tried to simulate as if I am using the Kafka third-party library. Okay, I'm not actually calling Kafka, but I have just tried to simulate here that I am directly calling the third-party libraries in my client code. I'm directly calling it. Tomorrow, what if I change from Kafka to RabbitMQ or something else? I have to go in each and every place. I have to change the code. It is hard coupling to a third-party library, my application. What is the other downside? I am doing so many things. Tomorrow, if some logic changes in order, in processing of the order, I have to come back, change this whole process order logic. I have to retest. I have to ask QA, please test all the order processing regression test cases. Then only we can be sure. This is make it better. Let's look at the better version of this code. Now let's take this. Look at this code. So short, so simple. What is it doing? The same thing. It's doing the validation. But what I have done, I have moved the validation logic into a new place. A more crisp, smaller code. It has a single responsibility. My job is just to do validation, whatever order DTO object you give me. That's it. Tomorrow, some new validation added. I am happy. I'll add it here. No worries. Simple code. Same way, when I want to do the mapping, doesn't matter how complex the mapping logic is, you have to call some different DAO, some tables, whatever, we will do it here. And I'm going to ensure that I'm going to map it properly and give it to you. Same way for the order service. In real world, save logics, persistence logics are very complex. This is again a simplified thing. Whatever logic change happens, I have to just change it in one place, only in the save method of order business service. Same way with message sending, I don't need to worry. I am going to publish the message here. Whatever format is there of the Kafka message, I will do it here. No one needs to care about. Now, if you go back and see such simple code, this is an example of a proponent of single responsibility principle. This follows single responsibility principle, because you have different classes who's doing single responsibility at a time. And now see, there is no third party dependency used here. It is kept only in one place. That's it. My code is smaller, crisper, easily readable. Tomorrow I have to do a change. I have to change the save logic. Okay, I'll just go and change it here. That's it. I don't need to change it in any other place. I need to add extra validation. Okay, I'll add it here. I add it here. Simple, no worries. These are the things that we should look at. Now, coming back to this. Now, let's talk about this last point. Okay, before we go to the last point, okay. So here we can see a comparison. Normal code versus better code following the SRP. Left side is basically the problem code, which was not following SRP. Right side is the one who's following SRP. You can see the difference side by side, how better it is, how clean it is, right? Now, we also talked about the red flags and the anti-patterns. We saw what was the red flag in order processor. There was hard coupling to third-party libraries. Another red flag in order processors, we had so many dependencies being added. Here it is 3. In this right side, you will see only 2. Now here you would say there is only 3 and 2, what difference it makes. But in the real life projects, when you see dependencies added, I have seen constructors where there are 15, 20 fields added in the constructor. It becomes so difficult to understand. Okay, so whenever you see large number of dependencies, you can understand it is a violation of single responsibility principle, right? Now, let's move to the next example. It is a twist actually. We will take the same example. Okay, so before really going forward, so basically the essence of single responsibility principle is you basically break one large class into multiple smaller classes. So in this case, if you see here, we have created order validator, order message sender, order mapper, order business service. So this order processor was broken down into multiple pieces. That is the essence of SRP. Okay, now there is a challenge. What is the challenge? What problem is created with this? Let's talk about this last point. SRP leads to class explosion. You see, earlier I had only one order processor. Now I have 5, 6 different classes. Now, the thing that you need to keep in mind is this can cause a problem. So you have to always be judicious that don't create very small micro level individual classes. Design principles are subjective. There is nothing written like a class has to be not more than 50 lines, or it cannot be, a method cannot be more than 20, nothing like that. You have to use your subjectivity. See, as long as the class and the method is manageable, understandable by you and your team, it is okay. There will be explosion of classes, but you can control that number of increase of that classes. You can manage it. You can use your subjectivity and your own judgment. But still, there will be classes more created that create the problem. Now let's take a variation of the same problem. Now this is the same code what we saw earlier. The order processor, but what this time I have done is I have basically created all these different methods. Okay, for each and every task, that is validation, mapping, save, send, I have created one method, and I have defined the utils. So utils is a very popular concept, right? Whenever like we don't understand what to do, we create a helper or a util. So we created a utils, we put all the logic there. We just kept on adding method after method, typically like we do, and did it. Now, nothing bad in that, but let's see what the problem happens. The problem happens is, again, it's violating definitely single responsibility principle, but it's better than order processor. Now, the challenge that happens is, let's say there are 2 clients. Client 1, he's calling the code. Now, the challenge is he has to do all the hard work. He has to create the utils object. He has to call validate. He has to call map. He has to call save. He has to call send. So basically, he has taken the responsibility of coordinating and calling all the steps to process the order. Okay, this is what they are doing. Now, let's say tomorrow you said, I'm going to now apply SRP. I'm going to break it down into small pieces. Okay, you did that. And there's also like order processing 2. He's also done the same thing. So there are two clients who are calling the same similar kind of code. Now let's see, you applied SRP. Now what problem happens? The problem that, so you applied an SRP and you broke it down into all different pieces. Now you created something called as an order facade. Now why I call it a facade is basically I have broken down to all the different classes now, but now the clients have a responsibility to refactor the code. Earlier they were doing this, right? Earlier they were doing this. Now, okay. Yes. So earlier they were doing this one by one, they are calling everything. Now what they do is they will basically call just one method. Okay. That is one way of doing it. So let's say there are like 10 different clients, you are using your code and now you have done the refactoring. And you said that you are not going to use that old code, it doesn't follow SRP. Now I'm going to give you good code, you follow that. So people say, okay, we will do it. We'll just call this one place, life is good. Okay, we will do it. Fine. The other client also goes. The other client will say, no, I am going to individually call all the methods that you have written. So you have written a validator, mapper, service, message sender. I'm going to call it one by one. That's fine. Okay. Someone does like that. Now, what really happens is if you see a problem here, all your implementation details are exposed to the client. The client has to remember there is a validator, there is a mapper, there is a service, there is a message sender. So many things are there, they have to remember. But instead of that, you can just say that, okay, I'll expose a facade design pattern, which does nothing but it will just provide you one single point of contact, only talk through process order of facade. Rest what happens inside, you don't need to worry. That's my head is properly. You created a facade and you just go and tell all the clients, please just use this facade. Your life will be simple. But imagine your API, order processing API is very important, right? And people are worried, I don't know, things will break. So let's just, have a backup. So what you could do basically here is you will say, okay, I'll have a feature flag, which will say that, okay, when the feature flag is on, I'm going to call your new code. When the feature flag is off, I'm going to call the old code, so that if there is any bug during refactoring, it will be taken care of. So this is another modification of the single responsibility principle. Okay. So now going back to the slider. So here we saw, so this is that second example. Here we saw in the left-hand side, the client is hard coupled. It has to follow all implementation steps. But if you see on the right-hand side, we implemented facade pattern and code becomes so simple. Okay. Now, single responsibility principle is also used by design patterns, all creational patterns, singleton pattern, factory pattern, builder pattern, everyone use singleton pattern. So single responsibility principle, because they are just focused to just creating objects for you. And second point, facade pattern. We saw the example how facade pattern came to the rescue. There was an explosion of new classes, but we could hide all those new classes behind the facade so that the coupling of the client code with your code is reduced, right? We saw it in example number 2. Now, before moving to open close principle, I'll just take a pause and ask any questions on SRP. No questions? Okay, I'll proceed to, okay, Shivam. Yes, Shivam.
Like when we break the classes, like for handling the different functionality, okay, in any form of like language. So can we manage our error handling in this pattern, like in this pattern?
Can you just repeat your question? I couldn't clearly hear it.
Like in the single responsibility principle,
Mhm. Yes, please go ahead. Hello, Shivam, I can't hear you. Hello,
Hello.
Shivam, are you there?
Yeah.
Yes, yes, please ask. Yeah.
So my question is that, like in this single responsibility principle, how can we use this method in our error handling? Like for example, if we want to, like for example, if we are writing a normal service request
Mhm.
or any HTTP method,
Mhm.
so how can through this method can we manage that error handling also in the same thing, or we can
Okay.
divide that thing?
Okay, so let me give you an example. Like, which particular language you work on? Programming
I
language?
work with a TypeScript and
TypeScript. Okay. Okay. So I can give you an example. Yes, definitely we can do that. We can create a separate exception handler where you can define all the different kind of exceptions that you want to do. And you can basically all your code wherever you want to call this exception handling, you can call this one centralized, maybe it can be one class or a group of classes who are related. Okay. So you can define one package of exception handling, which will have all the different exceptions, and you can write one or two exception handlers depending on the size of your project, right? If it is not a very big project, you can define just one exception handler, which basically covers all the different kind of exceptions. Or if you have a huge hierarchy of exceptions, you can basically have more than one, but you can have it in one package so that it is centralized in one place. Does that answer your question?
yeah.
Okay, okay. Good question, by the way. Thank you. Okay, so now moving to the next principle, open close principle. So what this basically says is software components should be closed for modification, but open for extension. Now we will understand this more with example, but the second point is very important. When clients ask to add new features and functionalities in product, they assume we will add code. However, so basically when the clients, the business analyst or whoever, the product, when they give requirements to us, they think we are giving new requirements, they have to write new code. But it's not always the case. We go and modify the existing code. We go and add some if condition, or we add some, and or clause in the existing code, modify it. We do all those things. But the client thinks that you are writing new code. What's the big deal? There shouldn't be any regression impact. But the truth is not like that. Why is it so? We have to understand that. And in order to solve this problem, whose help we need to take? Polymorphism and inheritance. These two things will help us. Okay. But a word of caution, never ever apply this open close principle when you're doing a bug fix for a production. Don't do it at that point of time. You will understand why in a few moments. Okay, so let's look at this code. So SRP, okay, OCP. So let's look at this example, OCP. Let's take a use case that we are, hello? Anyone is saying anything? Okay, so basically let's take a use case that we are, say a healthcare company. We have a product where we want to show the insurance claims. Basically, we want to calculate the insurance claims of the employees and the customers. So we basically give the insurance claim request, and we have to calculate what is the settlement amount that the insurance payers will give us. And every insurance company has their own proprietary settlement logic. Everyone have their own logic. Okay, so let's assume we are a new company. We build this new pass care claim module, and we have written this code. This is the first version of the code. Okay, so basically what I have is I have an insurance claim request object where I have the claim ID, payer name, payer code, which will be unique, claim amount, claim items. Basically, like if you have a medical claim, what all things you had claim for. Insurance type basically will be like it is a dental claim, pharmacy claim, medical claim, what it is, and the copay of the employee. So copay is nothing but you get certain amount after which you will be billed by the insurance company. So we get a simple request claim DTO object, and this is the V1 version of our logic. That let's say we have signed a contract only with one client, only with one payer. So let's say we have like say only Cigna. Cigna is a very big insurance company in US. We have signed contract only with them. And so we built a logic saying that if the plan if the insurance type is premium, then 90% you are going to get as the claim. If it is a gold and if it is a medical insurance type, and if the appliance type is gold, then you will get 75%. If it is a gold and it's a RX means pharmacy, then you will get 60%. And if it is a regular, you will only get 50%. And that too, I will deduct the copay amount from your claim amount. Whatever balance, I'll give you 50%. This is the logic we have for Cigna today. Now what happens one fine day, your business comes and says, hey, good news, we have signed a contract with another payer called as Aetna and with Anthem. These are two big insurance companies in US. We have signed contract with them. Now we have got new work, new money. So now you need to implement, you need to enhance. So everyone gets their change requirements. We also get the change requirement. We will say, okay, we will enhance the code. Earlier, the code was something simple. It was okay, it was manageable. So earlier we had code like this, simple sweet code of four or five if conditions. Now, when we implemented, now code has starting to look little complicated. Okay, we have added some conditions here, or condition and condition we have. Now things are not looking so simple, right? Now this is in violation of OCP, open close principle, because this code is open to modification. It's not open to open close principle, right? It's not open to extension. It's open to modification. It has to be close to modification, right? So now what do we do? To do this, we will take the help of polymorphism and inheritance. So now let's look at the better code. Now what I do is, basically I will go again to I will define something called as claim calculator, insurance claim calculator. I will define an interface saying calculate settlement amount, take this DTO, and I will define the payer code and the insurance type. Everyone has to define. Now first for Cigna, I'll go. I will override this method, and whatever logic was there in that V2 version, I will basically take this whole logic from here. I will take it here, and I'm going to put it in this Cigna Medical. Now this is manageable, and I will say my payer is going to be Cigna and my insurance type is medical. This is for Cigna medical claims. Similarly, I will create for Cigna RX. Whatever logic was there in that big if condition file we saw, I will copy that code and put it here. And I'll say insurance type RX, Cigna. Same I will do for Aetna, Anthem. I'll create for dental, medical, RX, Anthem. I'll create for everyone. Now what do I do? All I will do is history of calculators. Okay. In this case, what I'll do, I just create a simple instance. In your case, if you're using Spring or some framework, you will do your injections here. But otherwise, I just created new objects. I just created a list of calculators and I'll just add everything here. That's it. I'll just do it. And then I defined one factory, insurance claim calculator factory. What it does is I will just say fetch insurance claim calculator. I will give you the claim DTO. Get all the registry, get the list of calculators. I will just loop through it. In the claim DTO, the payer code and the insurance type. It matches with whichever calculator, that is my main calculator that I need to use. Okay, I'll just take that calculator and the same insurance claim calculation code, which was earlier this, which would otherwise keep growing if we get more and more contracts. But life will be difficult for us. But now it is just this. I just go call the factory. I just say fetch insurance claim calculator. I give you the DTO, check the payer and the insurance type, give me the calculator object. It will give me at runtime which particular calculator, whether it's Cigna RX, Anthem RX, Anthem Dental, I don't care. I will get it automatically and I will just call the claim settlement of that particular calculator implementation. I will call this, the call will come to here. It will do the calculation. It will return me the object. That's it. I don't need to worry about anything else. So now the advantage here is this code tomorrow. Imagine if you have to add new new calculator, you get new contracts. What you need to do? You just need to do two things. Write a new calculator by implementing the insurance claim calculator add it here to the registry. That's it. Nothing else that you need to do. This code is now open for extension, close for modification. There's no modification in this. Tomorrow, if you go and add another new calculator here, you don't need to tell your QA, please test for all the different pairs. For all the dental, medical, RX, you don't need to test all. You just need to test your code, because now your code is close to modification. This is the difference. What is the red flag for open close violation? When you see too many if else conditions, too many switch cases, understand that there is a violation. Code complexity has increased. Design pattern, strategy pattern, decorator pattern, they use these open close principles. We saw an example of strategy pattern here. If you see here, all these calculators are different implementation calculation. They are nothing but different strategies of calculating claims, right? So this is an example of strategy pattern also. So now taking a pause here. Any questions for open close principle? Any questions? Okay, I'll move to the next point, Liskov substitution principle. Liskov substitution principle says that objects should be replaceable with their subtypes without affecting the correctness of the program. Okay, we will understand what this means. Let's take an example to understand. Now we'll first talk about the violations. What is the violation here? Potential problems are, if you see there are some typecasting happening somewhere in the code, or you see a type check. You are checking the type of the object, and based on that you are doing some logic. Or if you see any empty methods or unimplemented methods, it's a red flag. There's some violation. So there are two solutions to it that we will see. So we'll see two examples here. So first example is, basically we'll take the example of Amazon. Okay, so let's take the example of Amazon. So Amazon has its own products, it's selling its products. So there's a product class. By default, like generally we give 10% discount for all the products on Amazon platform. But Amazon now says that we will have our in-house products. We will create our in-house products. The cost of manufacturing is less, so we can give more discount to attract more customers. So they said that, okay, I'll define a method, apply additional discount. Whatever discount is there, I will give 1.5 times of it. So if it is 10%, it will be 15%. If it is 20%, I'll give 30%. So okay, fine. Now there is a client class which is basically calling this code. Now what you do is, you basically say, okay, I'll have 3 products I want to buy. I want to know the price of it. So I buy a mobile, I buy a book, and I buy a Amazon Basics charger. So Amazon Basics is the in-house product. I want to buy its charger, it's cheaper. There's more discount. So you create in-house product, you put it into a list, and now I want to check what is the discounts I'm going to get for each and every product. So now if I run and see, what is the output I'm going to get? 10. Okay, so 10 is fine, but why this third item is getting 10? You said it's an in-house product, right? Ideally, it should give me 15% discount. Why it's giving me 10% discount? It's a bug. I complain to the customer support. Now, customer support says that, oh, sorry, sir, we need some time. We will fix and we'll let you know. So he goes back and tells the development team, there's a bug, you need to fix it. And then the developer goes, oh, okay, I got it, it's 15%. Okay, let me put a fix. I'll just put the fix in one day and just ship it out. So the developer goes, he fixed the code. He adds this if condition. And now we run the code. He sees that, okay, now I'm going to get 15%. Yeah, the logic is working fine. Now we are good. I roll out this code. But now the challenge happens is, the client code is now asking that what is the type of objects, and based on the type of the object you are deciding what you should do. So this instance of and this type checking is a red flag here. You should not do that. The client should not care what kind of product it is. It's a product, it should work. It's the responsibility of the product to tell me how much is the discounts. I should not be worrying that whether I need to apply additional discount or not. This is the red flag. This problem we need to solve. How? For that, we look at the solution. The solution is very simple. Now what I do is basically I go to this in-house product. I just call that get discount and just make a call to this before returning the discount object. That's it. I already had discount as 10 or whatever. And I just apply additional discount. That's it. Simple. And now my client doesn't need to worry and put checks like whether it's a in-house product, out-house product, what it is. It doesn't need to worry. So this is one kind of problem, that is type downcasting and type checks, which we do. And what is the solution? Don't ask, tell it. Right? Don't ask, tell it. Don't ask the client code. The code has to tell the client that you don't need to ask anything. We will tell you. Right? So left hand side is the problem code, right hand side is the fix for it, or the good code. Right? Now, what is the other problem to look out for? We have empty and unimplemented methods. We have these methods are there, which is empty. When you see that, understand there is a design smell, there is a code flaw, somewhere some problem is there. It's not a good practice. What you do, solution is break the hierarchy. We will see another example for this. Now, let's see this. Let's say an example is there. I am an SDFC bank, okay? And I want to show how much interest my customers are getting, or I want to show that basically. So I have basically defined an account interface which says that calculate the interest that has to be paid to the customer. Okay. Then I create a savings account which says that I will give 4% of the amount as interest. Then I have a fixed deposit. He will say I will give 7% as interest. Now the guy comes, he adds another one, home loan account. Home loan, I have a home loan account with SDFC, so that is also an account. Let's calculate the interest. But then the developer says that actually this account the bank is going to get, the customer is not going to get this interest, he has to pay the interest. Then the developer says, okay, no problem, just leave it. Either leave it blank or just throw unsupported exception. That's it. Don't worry. So we create, and now in the code, the client passes all these three accounts, and he said that let's calculate the interest the customer is getting. Now, when I run this code, the code breaks because someone added its unsupported exception, which is wrong. So now the developer will say that, okay, no problem. Let's a simple fix. You don't need to worry about anything. I will just go and just return 0.0. Simple, no problem, problem solved. You don't need to worry about anything. Okay, code will work, no worries. But this is not the actual solution. The problem actually lies in the fact that home loan account does not calculate interest that the customer is going to get. It is the interest that the customer has to pay. So you have actually tagged it under a wrong inheritance tree, right? The inheritance is wrong. So to fix it, the right solution is, now you will say, okay, let's break this hierarchy. I will create a new interface called as deposit account. And this time I will say the name of the method should be clear, calculate interest accrued to customer. And I will create another interface called as mortgage account saying calculate interest accrued to bank. And now I'm going to move this home loan account. I will be an implementation of mortgage account. Tomorrow, if I add car loan account will come under mortgage account. Fixed deposit, saving deposit will go to deposit account. Now the client code is very clear. They create separate customer deposit accounts. They will calculate all the customer deposit accounts, calculate and tell me the total interest that customer will get. For mortgage accounts, there will be a separate functionality, which will clearly tell me that, okay, this is mortgage accounts and this interest that is calculated, this is accrued to the bank by customer. Very clear, no confusion. This is an example of Liskov substitution principle, because now we are able to replace I can replace mortgage account with home loan account or say car loan account. I can replace that because the hierarchy is maintained. In the earlier case, what I was doing, I was basically, where is the home loan account? The home loan account was just defaulting it or just saying that I don't support, which is not correct. So This is Liskov substitution principle, where if I see empty unimplemented methods or unsupported methods, break the hierarchy, create a new hierarchy, fix the code for once and forever. Okay, this is the code that we saw. Okay, so this is the anti patterns and red flags. Whenever you see type checks, whenever you see forceful typecast, beware, think about it. Next is break the hierarchy. We saw the example just now. This is the screenshot for that. What is the red flag here? Unsupported methods. Beware whenever you see something like this, right? Now moving to interface segregation principle. This is the fourth one, which says that no client should be forced to depend on methods it does not use. So basically it means don't have interface which has so many methods, because most of the times interface, okay, yeah, Shivam.
In the yeah, in the previous method, we had seen like we break the hierarchy when we
Mm-hmm.
see certain exceptions are there.
Mm-hmm.
Let's example if I am creating a profile for a user for any platform, okay,
Mm-hmm.
and
Mm-hmm.
we have a hierarchy of user data. Like it can be personal
Mm-hmm.
information, then professional information, then
Mm-hmm.
educational information. All that the different levels of information we are saving. So
Mm-hmm.
in that method, can we utilize this kind of principle?
So you are saying your question is basically that you have different kind of user data, like personal, education, and certification, like all those kind of information, right? So now, like, what is your use case basically? How you want to apply it?
Yeah. And how this principle I can apply there to simplify this information saving? Because for a single user, there is a different
Mm-hmm.
levels of data with a single user only. The user is
Mm-hmm.
single, but the level of informations are in a different phases. So
Mm-hmm.
how we can implement this principle in breaking that
Okay.
to simplifying that information?
Okay, okay. Correct me if I'm wrong, as long as I understand your question. So let's say like you have different profiles of information. There could be like personal profile, employment profile. You could say you can say education profile, different kind of profile information. So if you are accessing all this information in different say different views or whatever in different clients, you can have one profile as one type will be your profile, and there could be like employment profile as one implementation of profile, and there could be like say personal profile as another implementation of profile class. Okay, so in this case, if you have something in common like the employment profile and the personal profile, the education profile, if they have some profile information in common amongst themselves, then you can define a hierarchy here. But if the informations are all uncommon, there is no commonality in that, then it doesn't make sense to apply this hierarchy. Does that make sense?
Yeah, sure.
Yeah, yeah. So basically, see, it all depends on your use case. If a use case has certain commonality, you can put it, but you have to really understand. Okay, I'll just go back to this point. I had to talk about this point. I perhaps, okay. Let me go back. Yes, sorry, I missed this point. The second point, the intent of the inheritance tree should be understood and honored. This is where I was talking about. We saw that example of account, right? We saw the
Yes, yes.
example of account. Where is this? In account, people thought that home loan account is also an account, right? But the account that we are talking about is basically the interest that the customer is going to receive. But in case of a home is converted, right? The intent is totally inverted here. Though apparently it looks that yes, it is an account. I agree it is an account, but the definition of the account interface is, if you see the definition, calculate the interest to be accrued or paid to the customer, right? So the intent of this account is different in this particular case. So using home loan account in this was wrong. And this is also another example of bad naming convention. In this, you should have perhaps called it as calculate interest. Like in this case, if you see, This name is more clear, deposit account, and look at this name, calculate interest accrued to customer. If this was the name, perhaps the one who was extending home loan under account would not have done it, right? The naming convention was also confusion. So it all depends on the context. In this context, account is basically a deposit account. That was the implicit context. However, the naming convention caused the problem, right? So it all depends on the context here. Okay, so I'll move to the next fourth principle, ISP, interface segregation principle. So basically it says that no client should be forced to depend on methods it does not use. Typically we have seen there are some interfaces, they will have lot of methods. When you implement that particular interface, you will see you only need 2 or 3 methods to override. The rest all you leave it, you don't care, right? Now what is the red flag here? Watch out for empty, unimplemented or unsupported methods. When you see it, it's a red flag, it's a bad design, right? What you should do, interface segregation, segregate the interfaces. So basically it says split or segregate the fat thick interfaces into thin ones. That is what it means. Okay, let's take an example and understand it better. Interface segregation. Okay, let's take the problem code. So let's take this interface. We need all Xerox machine, printer, scanner, fax, all everything we need. We have written some code so that we have created basically a software. Through that software on every employee's machine, we can basically give the command to give a print or to scan or to fax. I don't need to physically go to the machine and give that command. Okay, I have that functionality. So I defined a multi-function interface. It does everything. It does scanning, fax, print, everything it does. Okay, and then we bought a big Xerox machine. It is multi-purpose. It does everything: print, scan photo, fax, internet fax, everything it does. We also bought a new HP printer which does printing and scanning, but it doesn't do fax. So I said, no, okay, no worries, let it be empty. What's the big deal? Let's leave it. Then we bought a new Canon printer, color printer. We brought that. Then we said, okay, no problem. We have multifunction. Why to worry? Leave this as it is. This. Now, apparently it looks okay. It's not giving any compilation error. No problem it's giving. But this is a bad practice. It's a bad design principle. We will see. Why it is a bad practice is because now the employee, he sees that, okay, Xerox machine is busy. Okay, let me go to the Canon printer. I can see scan and fax also function is also available for me. Let me call that. Okay, he calls that, and then he says that, oh, nothing is happening. Why scan is not happening? Huh? Then he goes and checks with the support. I'm giving this scan, it's not working. It's not working. Then that guy says that, sir, this is a Canon printer. How will scan work? Then you will say, then why you have given this functionality? I am an end user. I saw that button was enabled. I clicked it. You should disable it, right? It's so confusing. This is the problem, right? So now what do we do with this? What is the solution? Solution is break this fat interface into thin interfaces. So what I do is I create one print interface, I create one scan interface, I create one fax interface. Now simple solution. I created 3 new interfaces. I create fax, I create print, I create scan. I created 3, and now simple thing for me. I don't need to do much changes. Xerox machine will implement all 3 interfaces. HP printer scanner only needs print and scan, it doesn't need fax. Canon printer, it only needs print function. Simple. The code is neat. See how simple things became, right? So this is the application of interface segregation principle. Wherever you see fat interfaces, you see unsupported, unimplemented methods, you basically split that. One thing, what SRP, single responsibility principle, is for classes, interface segregation principle is for interfaces. So here basically we are defining single responsibility for each and every interface. So you can see ISP and SRP are correlated. Okay. So now I'll take a pause. Any questions on this? this is the code we have. Yeah. Okay, I think I'll proceed. I think there are no questions. So let's move to the last principle. Thank God. Okay, so this is the last principle we have. So this principle, I know everyone said that no one knows about solid principles, but I'm sure that some of you have unknowingly used this design principle some way or the other. We will know it after some time. What does the definition say? High level module should not depend on low level modules. Both should depend on abstractions. And the continuation to it is abstractions should not depend on details. Details should depend on abstractions. Now let's understand this, what it's trying to say actually. What do you mean by a module? A module can be anything. It can be at an application architecture level, it can be a microservice. Like in this case, order module, payment, order microservice, payment microservice. In an e-commerce application, both are two different applications. Order is higher level module, payment is lower level module. It can also apply on an individual class or a package. Product catalog.java, product repository.java. These are two modules. Product catalog is the higher module. Product repository is the lower module. What does dependency inversion say? What we should do? What it says is basically high level module should not depend on low level modules. Both should depend on abstraction. If you see here, product catalog is directly dependent on product repository. There is no abstraction. Abstraction means type basically should be there. So here if you see, the better design is basically we should have an interface. Let's take this example. Left hand side, product catalog is dependent on SQL product repository. This is the implementation, right? It directly depends on that. There is a hard binding. There is a hard coupling. Okay. We want to reduce this coupling. We should always try for loose coupling. So for that, we define an interface, product repository. SQL product repository implements product repository interface. Now product catalog talks to product repository. It doesn't talk to SQL product repository directly. Okay. That is the thing we are trying to achieve. Why? Because it will give us loose coupling. Let's understand it with an example. So let's see the problem code. So this is it's a simple code I have taken. Ideally, it will be like some database query will be written. It will be getting some data. But let's say we are getting this list of product names. Okay, this is an implementation. Now I have the product catalog. What it does is it calls this SQL repository, get the names, and then prints it or passes it to the higher level module. It does that. Now, what is bad about this? It's fine, right? But the downside is, so if say from SQL, you say, I want to use now MongoDB. I want to use MongoDB for storing my products. How do I do it? So now you'll say, okay, no problem. I'm going to change the code. I'm going to write a Mongo product repository. I'm going to write the logic. You'll say, okay, fine, no problem. We will change it. But now what is the downside? The downside is in each and every place, wherever you have called SQL product repository, you have to go and change the code. Every place you have to change the code, right? That is the hard coupling, right? That we have. That is, so we need to go for loose coupling, low coupling. So for that, what we do is we define a product repository as an interface, and the SQL product repository will implement that interface so that this implementation is hidden behind this abstraction. And now product catalog will talk to product repository. It doesn't care whether it's a SQL or whether it's a MongoDB, what implementation, it doesn't care. Okay, it just gets this product repository. We just create a factory. Let's assume there's a factory. It could be an application framework level or whatever. The factory is giving me the product repository type object. What it is inside, I don't care. The product catalog doesn't really care about the types. I just want a repository object which should give me the product names. How it is implemented, it doesn't matter. Tomorrow I change it to MongoDB, no worries. The client code is not impacted. We will just swap the SQL repository with MongoDB product repository. So the code is here loosely coupled. Your application is loosely coupled to changes, right? So this is what we achieve through dependency inversion. Now, you might have heard about these two things, dependency injection and inversion of control. People who have worked on, I think, .NET and Java and all, you might have heard about these things, inversion of control, dependency injection. These are nothing but programming practices built on top of dependency inversion principle. Frameworks like Spring, Google use are all using dependency inversion because they are all dependency injection frameworks. So dependency inversion basically encourages loose coupling. It exploits the best practice of programming to interfaces, right? Now, any questions on dependency inversion? Okay, so now coming to some potential offenders and red flags, what things you should remember. If you see helper classes, utility classes, and you see lot of code is put inside, lot of functions have been put inside that, then it can be a red flag, a violation of single responsibility principle. Sometimes you will see user interfaces where business logic is built into the UI layer also. That is again an example of single responsibility principle. User interface should only focus on building the UI, not business logic. Classes, such kind of classes are called as God classes. It's a classic anti-pattern. God classes is a classic anti-pattern. Basically, in every project, you will have some classes, which is very huge. Like I gave the example in the beginning. I had classes like 20,000, 25,000 lines of code in one class. For any change I have to do, I have to go and make a change in that class. Everyone has to change code for every feature, every request. These are all God classes. This is not a good practice. Next point, if you see explicit instance of checks, type checks on the objects, we saw in risk of substitution, we were checking if this object, if the product is of type in-house product or not. These are all like red flags. Then if you see code is not supported, or you see empty code, or if you see high number of conditional statements, these are all red flags that you should take care of. Okay, I think I'm done. I'm done from my side. So this was in fact the last slide. So I'm done from my end. Any questions? Yes, Shivam.
My question is like generally we use try and catch method like for success and failure cases in many of our TypeScript and different languages. So what is the best method in that through solid principle we can generalize that try and catch method properly? What is the most basic thing we can write in try and not we can write in catch method like this? If anything you can explain, that will
See,
be helpful for us.
okay, so see, try and catch is basically for exception handling. So here, basically, it's difficult to generalize things. Okay, until and unless like you have a like a common decision that you want to take. Because see, when you do try and catch, it's basically you are saying, I know what to do when this problem occurs, right? So one way is either you throw the exception, you basically declare the exception. The other is you handle the exception. Now, when it comes to handling the exception, if you know that for all kind of exceptions that I get, this is the generic corrective action that I need to take, then you can write a centralized exception handling method for that, and you can use it everywhere. But if it changes from place to place, like in one particular place, you have a specific correction that you need to do, then you'll have to write a separate code. If there is a separate correction that you need to do in another place, you'll have to write a separate code. So it depends on a use case. If you have a common correction action that you have defined for the entire application, yes, you can apply single responsibility principle there, and you can have one centralized class.
One more question is there. Like when we build any feature which is in a complex way. For example, let's example, I am talking about a query builder. In UI, if I want to query builder, lots of conditionings are there in there. Lots of indexing when we have to maintain to retrieve the data, because like there is a to and fro. You have to create the data and create a UI and get the data, and sometimes with the data you have to create the UI. In such a complex
Right.
component, if the complexity is high and there
Mhm.
is a sensitivity of data is very much there, like if somewhere we play miss the data, then the whole
Hello, I lost you, Shivam. Shivam, I lost you.
yeah.
Yeah.
So if like in that if any component have a complexity there, how we
Mhm.
can break those complexity in a smaller things, like so that like when we read the code, it will be easy for us to understand. Okay, this is for this
Okay.
and this is for this.
Okay. So in this particular case, you are saying that you have a query builder. You have to do like, you have to build a query like there could be like and conditions. You'll have like joins, these many kind of different things, right?
Yes,
If I
yes,
understand it.
yes,
So basically, in this particular case, you can have a separate component or a class for a particular clause, right? And you can use it at runtime. Basically, when you are, so let's say you get a query where you have to like build the object, and based on that, whatever is your clause, it could be like your joins, or if you are doing basically a where clause, whatever you are doing. So at that point of level, at runtime, you can have different I would say clause specifiers. So clause specifier will be different clause specifier, and you can add them at runtime based on the query you want to build. So basically you have a hierarchy, and at runtime you have different clauses which are implementing that hierarchy, that type. And when you are building it, you are like applying a decorator pattern kind of thing. If you understand decorator pattern, at runtime, I'm adding more and more features. So in your case, when you are doing query building, so at that point of time, whichever clause builder you need, you can just add it at runtime. So that way you can break it into smaller pieces. And whenever you have to do any change, you do only in one specific area, and it doesn't tie your whole code, right? Because based on your requirement, what kind of query you are trying to build, it will help you to do that at runtime. Does that make sense to
so
you?
like you want to say, like for example, if any functionality is a very we are like when we write any function and it seems like it becomes so lengthy and to read
Right.
it, so
Mhm.
is like we can break those things in a smaller
Mhm.
way
Right.
through creating a small units of that from units in a different, and there should be a main function that is handling all the units.
Right. Right. See, the point is basically whenever you build a feature, is it an existing application, new application, whenever you build a feature, give as less as possible entry point to your logic. So if you are building building a feature like we saw for order processing, there has to be minimum one entry point, maximum maybe two or three if the functionality is very big, but try to minimize the number of entry points to your code. You hide all your implementation behind that main entry point, which is your kind of a facade, or which is kind of the wall. That is the interface to the outside world. Whoever client calls, don't expose it to your client codes. Otherwise, what happens? Tomorrow you change your implementation, you have to go and change in all the places where you were using that code. Got it? So always try to hide your code behind one wall or the facade. There has to be one or two just entry point. So tomorrow, if anything changes, the impact of change is less on the calling code, right?
Okay.
Yeah.
Thank you so much.
Yeah. So I think these are just my closing notes, like for the day. Like I have already gone through. I would only say that, solid design principles is something which cannot be measured. It's subjective. So always use your own judgment. There is no rule book about design principles. You have to use your judgment. As I told you, need not create very micro level classes. It can be little big also, but as long as you can read it, you can maintain it, you can do it. If tomorrow that new micro class becomes bigger, you can break it later, but need not do it in one shot only, that I will create only 10 lines of class in each place. Nothing like that. Okay, use your judgment, use your subjectiveness in that. Second thing, it's hard to get these design principles right in the first shot. So whenever you code, try to just write the code, make the functionality feature work. Once it is there in place, then think about red flags, anti-patterns, try to apply whatever design principles applies there. So do it that way, don't try to do it the first time. And the second thing is, keep revisiting your code, keep refactoring it from time to time, see wherever you can do refactoring, and always do it in baby steps. Don't do refactoring, big refactorings. Do it always in baby steps, and keep doing it like gardening. Keep doing it regularly. Don't do it like once and then forget it. And last, most important thing, always try to write JUnits or NUnits, whatever like language you have. Write unit tests with good coverage, because when you do refactoring, you are assured, because your code is going to pass those test cases even after refactoring, right? So with that closing thought, thank you so much. I know I have taken a lot of your time. It's almost like 1.5 hours. I'm very sorry for the overstretch, but it is my honest strive to make you understand this. And I will just say that I'll share all this content with you. I'll share the code. I will share this PPT with you. So go through it and see those examples, report it, and try to apply it in your day-to-day lives. This thing will definitely help you to be better as an engineer. It will make your life more easy. Whatever projects you're working on, you will definitely see the benefits later. So with that closing thought, thank you so much, Saurabh, for giving me this opportunity to talk to you guys. So that's all from my end. So again, like any questions, any thoughts you have, it's over to you guys now.
Guys, any queries? Okay. Thank you, Devesh, for your time. Thanks
Thank
for
you
your
so much.
valuable
Okay.
insights in today's webinar.
Yeah, sure. Thank you so much for inviting me. Yeah, all the best, guys. Thank you so much. Bye-bye.
Thank you. Thank you, sir. Thank you so much.
Thank you.
Thank you.
Thank you, sir.
Thank you.